Hello students, we're going to look at solution now to number 13. It's the first full solution, long answer question, part of your chapter 1 sample quiz in book 1 of your Math 1026 booklets. And it gives us a triangle ABC, and it gives us 3 vertices. The triangle's already sketched for you. The vertices are A, 2, 3, so let's write that in. A is 2, 3. B is negative 5, 4, so B is negative 5, positive 4. And C, down in the fourth quadrant, is negative 1, negative 2. Now, if it's not sketched for you, that's the first thing you should do, okay? And label each vertex like I've done here. And the first question is asking us to find the midpoint of BC. So I'm looking at side BC. So the midpoint will be the point right in the middle of that, right? Somewhere right there. We'll call it M for midpoint, and it divides the line into 2 equal pieces. So now we can't read it from the graph paper because we don't have the units, the grid on it. But it looks to be negative 3, 1, negative 4, 1. But we're not sure. Now, we can determine it by using the midpoint formula, and I'll write that here. And we know the midpoint formula is one where you add up the 2 x's, right, and divide by 2. So the midpoint formula uses x1 and x2, but we add them, right? So we just add up the y coordinates, divide by 2 as well. So pretty straightforward. Now, here's x. I'm going to call this one x1, and I'm going to add to it x2, right? So there's x1 plus x2. Let's call it m. So m equals x1, negative 5, plus x2, negative 1, divided by 2. So that's negative 6 over 2. The y coordinates are going to be y1 plus y2. So 4 plus negative 2. All over 2, and that of course gives us 4 plus negative 2 is 2 over 2, and then simplify if you can. Negative 6 over 2 of course is negative 3, and 2 over 2 is 1. So the coordinates of point M, and I'm going to write that next to it, is negative 3, 1. So we found the midpoint. Now, next question, find a distance, okay, length, same thing, from A to the midpoint of BC. So we want this distance. I'm going to sketch that line in. Let's put that line in a different color. Let's put it in black here. So we want this line from here to here, the length of that line. Now, do we know the coordinates of A? Absolutely. So we're going to use A, which is 2, 3, and we're going to use the midpoint of BC, which we've called M, right? And we're going to use m, which is negative 3, 1. Of course, we need the distance formula, and that's given to you as well. You don't have to memorize that, but most of you know it. Now, in the distance formula, you subtract, all right, and then square those values plus subtract the 2 y values and square it, add them together, take the square root. And we developed that formula in class. I'm sure your teacher did. It comes from the quadratic formula. Now, not the quadratic formula, sorry, the Pythagorean theorem. Okay, so have a look at this one. How are we going to do it? Well, some people actually label their letters, and that's a good idea too. They'll write the letter, which one, right over it. So if I call 2 x2, then over here that would have to be x1. That means 3 must be y2. X2 and y2 are in the same ordered pair. And 1 over here would be y1, wouldn't it? So plugging those values in, what do we get? We get x2, which is 2, subtract, now that's a subtract from the formula, but this is also negative here, so you're going to run into minus a minus, right? So that's negative 3 all squared, and then we have plus y2, which we called 3, subtract 1 all squared. So moving up here to get a little more room, so the distance. Now you can use the distance of, you can call it like this. You can label it AM or MA, or you can just use the capital letters AM. So either or will do. Alright? So the distance of AM here, I'm going to get 2 minus a minus 3. That's 2 plus 3 now, isn't it? Squared plus 3 minus 1 is 2 squared. So I get 3 plus 2 squared, which is 5 squared, which is 25, plus 2 squared, which is 4. So it looks like the length of line AM is root 29. Now, did it say leave your answer as a radical? No. So you can get the decimal if you want, but I would just leave it like that unless your instructions tell you to go to a decimal. Alright, and question C is now asking us to find the slope of a line parallel to BC. Now, parallel means they have equal slopes. So all you have to do is find the slope of BC, and that's your answer, because a line parallel to BC means a line with an equal slope. So parallel lines have equal slopes, so it's the same slope as BC. So we're going to use the coordinates B and C to find the slope. Now, what's the slope formula? y2 minus y1 over x2 minus x1. So again, which one do you call y2? I'm using B and C. Let me just highlight them once more. B here and C here. Okay? So doesn't matter which one you start with, just be consistent. If I start with this one to be y1, and then 4 is y2. Right? Doesn't matter which one you start with. So I'll start with -2. Call that my y2. Subtract y1, which is 4. That means if I start with -2 and go this way for the y's, I must do the same for the x's. Start with -1 and go to 5, right? So on bottom I'll have -1 subtract a -5. Be careful with minus and minus, right? Minus in front of a negative. So that's -2 minus 4, that's -6 over -1 plus 5. So that's a -6 over +4. Now that reduces, right? We can divide each of those by 2 because they're both even numbers, leaving me with an answer of -3 over 2. So the slope parallel to BC is -3 over 2. So there's a complete solution for all parts of number 13.